How an antenna transmits all starts with a transmitter. The transmitter generates a high-frequency alternating current, AC, signal. This signal operates within specific frequency bands, such as VHF, 30 MHz to 300 MHz, or UHF, 300 MHz to 3 GHz. The electrical signal is modulated using techniques like AM or modulation encodes information such as voice, data, or video onto the carrier signal. Radio frequency, RF, signals are transmitted from the source to the antenna through a coaxial cable or waveguide. The antenna receives alternating voltage and current from the RF signal at its terminals. Upon receiving the RF signal, the antenna prepares for signal radiation. Coaxial cables and waveguides serve as conduits for RF signals, ensuring efficient transmission. The alternating voltage and current at the antenna terminals are crucial for effective signal transmission. The antenna's preparation involves converting electrical signals into electromagnetic waves for radiation. Alternating current, AC, arriving at an antenna causes free electrons within the metal conductor to oscillate. The oscillation frequency of electrons matches the frequency of the incoming radio frequency, RF signal. Electron oscillation within the antenna is a prerequisite for electromagnetic wave creation. The oscillating electrons generate electromagnetic waves, radiating energy outwards from the antenna. Oscillating electrons generate time-varying electric and magnetic fields, as described by Maxwell's equations. These electric and magnetic fields couple together, forming an electromagnetic wave. The electromagnetic wave radiates away from the antenna. The electric field, E field, and magnetic field, H field, are perpendicular to each other. The electric and magnetic fields are also perpendicular to the direction of propagation of the electromagnetic wave. The shape and direction of electromagnetic wave radiation depend on antenna type, wavelength, and antenna length. A dipole antenna produces a donut-shaped radiation pattern. A Yagi antenna focuses the signal in one direction. Antenna length is typically a fraction, e.g. Lantwo, mu5, Da3, 2, or Lantwo, mu5, Da3, 4, of the signal's wavelength. Electromagnetic waves propagate through free space or the atmosphere after being radiated. Reflection occurs when electromagnetic waves encounter large objects like mountains or buildings. Refraction happens as electromagnetic waves pass through different air layers. Diffraction causes electromagnetic waves to bend around obstacles. Attenuation weakens the electromagnetic wave's signal strength over distance. Atmospheric conditions and obstacles in the environment affect electromagnetic wave propagation. In an aircraft's VHF communication system, a pilot's voice is converted to an analog signal. The analog signal is then modulated, typically using amplitude modulation, AM, and amplified. This amplified signal travels to the VHF transceiver and then through a coaxial cable to the VHF antenna on the aircraft fuselage. The VHF antenna radiates the signal as electromagnetic waves at a specific frequency, enabling communication with ground stations or other aircraft.